Hello, how are you doing, my friends? Today I'm back with another video on Mastercam case study, and the topic today is how we can control the feed rate, how we can optimize the feed rate uh, in Mastercam. Maybe many people have a question like how I can reduce the feed rate when the tool comes to a small corner, or maybe how can I optimize the feed rate uh, when I do the cutting, uh, how the tool can accelerate when the material cuts it less, and how reduce the feed rate when uh, the tool engage much material. Okay, so I hope this video can answer some question. And in this video, I want to talk about a function in Mastercam that's available in the previous version of Mastercam, not only in 2017. You can find it on maybe Mastercam X6, Mastercam X7. I think this is it, but not so many people know about this, and maybe not so many people ever use it. Okay, this is the function I want to talk about is the Highfeed function. You can see it set an icon with I have a tool with the red around here. That's called a Highfeed function. So if you want how what's the Highfeed function, you can click on this. Oh, sorry, you need to create a toolpath first. So I will talk about this first. Is the Highfeed function is allow you to control the feed rate, to optimize the feed rate when you do the roughing operation or do a finished operation. Yes, this function work on both finished and roughing operation. Is control the feed rate. Yes, it can reduce the feed rate, it can increase the feed rate based on the value you define. Okay, first I will show you this is my part on the screen. You can see this is a sample part, not so complicated, but when I created it, you can notice that I make some error that have small corners. So I will describe how this function work. You can see the corner which I mark in red color is the error that has small radius. For example, this one, I will check the radius of this corner. You can see the radius is 5.5 millimeter. And how about this one? We check it, and the radius is 6 millimeters. So I will use a tool which have radius is nearly equal to this, so you can see how this function work. Okay, and I also make a stock definition. You can see this is the stock. Okay, first I will create a high-speed toolpath for roughing operation. Okay, we will cut this. We will cut this profile first using the dynamic toolpath. Okay, we go to the toolpath here and click on dynamic. Machining region, we will use the stock definition for machining region, and for avoidance region we will select this chain. Okay, and we will cut from outside of the part. In this case I will use a big tool, for example 16 millimeter tool for the cut, and I'm input feed rate for this. For example, I will cut at a feed rate of 3000 millimeter per minute, and we don't care about the spindle speed. You can input it if you want, for example 8000 round per minute. And in the cut parameter, we will input a step over, for example 10% of the tool diameter, and the minimum tool path radius, and the back feed rate, stop to lift. Okay, and the depth of the cut. Okay, so this is our first roughing tool path can see that this is the roughing toolpath. We'll cut this profile. Okay, I will change a little bit. I will set the first part offset is to 3 millimeter, so the tool will engage far away from the part. You can see tool will not engage from the first pass of cut. Yes, it still not touch the stock here. Okay, this is an example of the roughing toolpath. I will create another toolpath to cut the upper area here. Okay, we'll copy this and I'm gonna select another avoidance region like this one. Okay, I will change the depth here. Okay, we bring it in here. Okay, we will cut from top to the bottom. First we cut this level, and this is the first cut, and this is the second cut. Okay, you can see in this roughing operation, when the tool engage into the corner here, yes, you can see tool will engage a lot of material, and many people, and it makes sense if you can reduce the feed rate when the tool engages a small corner here, like in this area. You should want to reduce the feed rate when the tool cut into this area, because yes, the cutting direction change very often. Yes. Okay, so what you want? Yes, you will want to cut use the high feed rate when the tool cut outside, and you reduce the feed rate when the tool cut into the small corner like this. Yes, and you also want the feed rate can reduce when the tool go to a corner like this. When the tool change direction like this, you want to remove reduce the feed rate. Yes, the high feed function will do it for you. Okay, so we got two roughing operation here, and I will create two more finish operation. Okay, this is another contour tool path. To finish this operation, I will select okay 11. Okay, I will select a 10 millimeter. All right, 10 millimeter. Okay, 10 millimeter and mill. Okay, change the cutting length. Yes, okay, and we cut at a feed rate of for example 1500. Okay, the feed rate spinner speed is 8000 round per minute, and we do a finished cut here. All right, change the lead in and lead out. Okay, this is the finished cut. Yes, you can see this is the finished cut with a 10 millimeter diameter flat end mill. You can see in this corner, you may want to reduce the feed rate when you do the cut here. Yes, this is a small corner. You want to reduce the feed rate when the tool go here, and okay, another one, the bottom, we channel. I will select this chain. All right. Ping. Okay. With the tool. Okay, I will use a little bigger tool. For example, the 11 flat end mill. Okay, 11 diameter, 11 millimeter diameter end mill. Okay, so you can see there's a sharp corner here with the tool diameter is equal or bigger than the corner radius. Sorry, the tool radius is bigger or equal to the corner radius. So you can see a sharp corner here in the tool path, and normally if this happen, the surface finish here in the corner will very bad. So you want to reduce the feed rate, maybe the spindle, or at least the feed rate on this corner to a very low value. Okay, so so far we have two roughing operation. Yes, it's a roughing, and this is the finish. We also have two finish operation. Finish. Okay, two roughing and two finish operation. All right, let me talk about a Highfeed. Okay, this time let's talk about a Highfeed function. To use this, you must select a toolpath to apply the function. Okay, for example, I want to apply the function to the roughing toolpath first. Okay, I select the first operation, and I'm going to click on the Highfeed function button here. Click on this. If you want to know what's the Highfeed function, you can click on the half button here. Mastercam will to tell you what the Highfeed function. Oh, sorry. You can click on the Highfeed machining here, and Mastercam will let you know what's the Highfeed machining, what's that function, and how that work. Okay, I can make it quick. The Highfeed machining will based on the the operation. If you apply this function on a finished operation, Mastercam will calculate the feed rates based on the machine dynamic. And if you apply this function on a roughing cut, Mastercam will calculate using the optimum stock removal. Yes, stock setup. Okay, and you click on here and you will see what happened. All right, you can see here. If that's a finished operation, Mastercam will use the machine dynamic parameter to calculate the optimum feed rate. And if you apply the Highfeed function on a roughing toolpath, Mastercam will calculate based on the material removal. Yes, the optimum chipload. Mastercam will calculate using the chipload to calculate the feed rate, the optimum feed rate. Yes, so if you want to apply it into a roughing operation, you need to define the stock. Yeah, just keep in mind that if you want to apply this function on a roughing operation, you need to define the stock, and it's no need if you apply it on a finished operation. For example, I want to test it on a finished operation first. Okay, for example, the last operation here. Now you can see the feed rate will not change. I will show you the feed rate. You can take a look at the feed rate here. The feed rate will be constant at 1500 millimeter per minute. Okay, you can see the feed rate will not change when the tool go to the corner. When the tool change direction, the feed rate keep the same at this value. Even the tool go to the sharp corner here, you can see feed rate will not change, and that's what we don't want, right? That's the constant feed rate. And now when you want to change the feed rate to optimize the feed rate, you can use this Highfeed function. Select this operation and click on the Highfeed button here. Because this is a finished operation, so we're gonna check on this. With the finished operation, there's no much material to be removed, so Mastercam will calculate based on the machine dynamic parameter. Okay, and you can click on this, and you don't need to define the stock because this is just a finished operation. And then you click on the OK button here and click on the run button, so Mastercam will calculate the feed rate. Yes, after that you can see the noted when Mastercam finished the calculation. You can see before you apply the Highfeed function, the cutting time is 33 this 33 second, and after you apply the Highfeed function, the feed rate the cutting time will be 39 seconds. Yes, 6 seconds longer. And you can see the reduction rate is minus 18%. That means there's some play that the feed rate has been reduced, so you can see the cutting time is increased. Yes, that's what we want, right? So after we apply the Highfeed function, the tool path will be locked. You can see that we have a lock symbol here, and you cannot change any parameter in the toolpath. The toolpath is now locked. Okay, and if you want to change the parameter and regenerate, you need to unlock the toolpath first. After you apply the Highfeed function, the toolpath will be locked and you do nothing with it. Now I will check again with the feed rate. Okay, all right, now you can see the feed rate is now 125 when the tool go to the when with the lead in motion. The feed rate is 594, and you can see the feed rate change now is when it run here from here to here, the feed rate is maximum rate 1500. Okay, and when the tool go to the corner, you can see the feed rate now reduced to yes, you can see this reduction. Yes, reduced. And when the tool go to the corner, you can see when the tool go to the corner like this one, you see the feed rate is reduced to 1125, and now it just become 125, yet very low. The feed rate has been reduced a lot when the tool go to the sharp corner here, and when it go out of the sharp corner, the feed rate increase. Now it's 1500. Yes, you can see that even if it go to this corner, the feed rate has been reduced also. That's why we have a longer cutting time. And you can see the feed rate change based on the tool position. Yes, when it go to the corner here, feed rate reduce a lot, and you can control how the feed rate change by go to the machine dynamic parameter and modify some parameter. Okay, and now we're gonna move to the machine dynamic parameter to see how we can control the feed rate. Okay, to go to the machine dynamic parameter, you should move to the machine tab here and click on the machine definition. In other previous version of Mastercam, you can go to the same, go to the machine uh, definition manager. Okay, wait a minute. Okay, and you can see the window machine definition manager open, and then you're gonna click on this button that's called edit general machine parameter, and you move to the machine dynamic tab here, and this is where you control the the feed rate of the Highfeed function just for finished cuts only. Okay, you can see we have some parameter that will control the feed rate. To know what is parameter mean, you can go to the click on the have button here and go to the field definition. Mastercam will explain what is parameter mean. Okay, for example, uh, you want to know what is the look ahead parameter mean, so you can click on this look ahead here. Mastercam will explain what this the mean. That's very simple. Okay, for example, we have a parameter called maximum feed rate change per flock. Now if you want to get a smooth acceleration and deceleration, you can input another smaller value, for example 200. So this block we have an increment and a reduction of 200, not much, so we get a smooth feed rate. We have another parameter called slow to minimum corner feed rate when direction change at 90 degree. That means when the tool direction change at an angle of 90 degree or smaller, the feed rate will be automatically reduced to the minimum feed rate. That's the value we declare here, 125. So if you want to make a slower feed rate or a faster feed rate, you can input another value. Okay, we'll make some change, and now we see if we have any different. To generate this toolpath again, you need to unlock it first. Click on the regenerate, and then we will apply the Highfeed function again on this toolpath to see if there any different. Ping, and you can see now the time is up to 49 seconds. That means we have some change. Okay, you can see the feed rate now 1000, and go to 250. That's the minimum corner feed rate. And now the feed rate increased, but not much like the previous example. You see now it's increased to 650, 850, and 1050. Yes, it increased, but not much. It's smoother, and now it increased in the same way. Now it's the 1050 to 850, 650, and now 450 and 250. At least is the minimum corner feed rate. And when is the acceleration? Accelerate it will increase step by step, a little amount at a time. Yes, so this is the finish function. We will do it the same with this fit this toolpath. Okay, ding. Now you can see before we apply the Highfeed function, the cutting time is 17 seconds, and after we apply, the cutting time will be 25 seconds. And we can see if there's feed rate. Now when the tool go to the corner, you can see the feed rate is reduced. Yet very low. now it's only more than 500 millimeter per second, and now it increase back. Yes. So for the finished operation, Mastercam will calculate the feed rate, the optimum feed rate based on the machine dynamic we declare in the machine definition. And how about the roughing toolpath? This is the roughing toolpath. With the roughing toolpath, Mastercam will use not only the machine dynamic parameter, it's also use the material remove material remove rate to control the feed rate. That means you must define the stock. So Mastercam will make the calculation based on the stock removal and the machine dynamic. Okay. Now we will apply the Highfeed function for the first operation here. Thing. Okay, now because this is a roughing operation, we need to select roughing and finish. Here we get some parameter. This is the minimum feed rate when you apply the Highfeed, and this is the maximum feed rate. This is the maximum air cutting. That means when the tool cut make the movement with no cut material. If we apply this feed rate, we have up feed rate scale factor. That means when doing a 3D tool path, when a tool go the up direction, Mastercam will use this factor to multiply with the current feed rate, and when the tool go in the down direction, that means from the high place to the lower place, Mastercam will reduce feed rate and reduce by multiply the feed rate with this factor. Okay. And as I told you, because this is a roughing tool path, that means there's a lot of material removing motion, so we need to declare the stock. So Mastercam we can do the calculation. You can use the stock definition here, boundary block here. Mastercam will take the stock boundary that we define, and now we do the calculation. Okay, and now we do the calculation. You can see after Highfeed applying, we have the machining time from 1 minute 42 seconds to 3 minutes and 7 seconds. That means slower. Okay. Alright, and you can see here, this is the dynamic tool path, and we see when a tool did not cut into the material. This is when Mastercam apply the machine dynamic parameter to calculate the feed rate. You can see the feed rate change. And let's see, we have a feed rate of more than 3000 here. And when it go to the corner, like this, the feed rate reduce. And how about when the tool go to the corner, like this one? Yeah, you can see this, the feed rate is reduced a lot. Because we set the minimum feed rate is 1000, so this cannot reduce to a lower value feed rate. The minimum is 1000. If you want to reduce more, you can input the minimum a smaller value. Okay, for example here, we have the minimum feed rate 1000 here. When the tool go to the sharp corner, the small corner here. Okay, that's how the Highfeed function works. You can try another one, this, and apply the Highfeed function. We keep, now I will reduce it to 500, and maximum feed rate can go up to 5000. Stop setup, boundary box, okay. And we can do the calculation. Yes, the machining time is increased, you can see. That's because the feed rate have been reduced based on the stock we declare. Okay, you can see when the tool engage to this area, feed rate reduced to the minimum value 700, like this one, 900 and 700 in the corner here, where the tool cannot make a good cut. Okay, so that's all for today. I hope after this video you will have some you will know about the Highfeed function in Mastercam, and you know how to control the feed rate, how to optimize the feed rate when you do the cut. Okay, that's all for today, and I hope to see you in another video. Okay, goodbye and have a good night. I love you all.